the moving source. Today's topic is clear: radiation from motion. We will understand it using classical theory. This discussion comes from Feynman's lectures, Volume 1, Chapter 34. We are not quoting, we are explaining, in our own words. And this chapter closes classical optics. Until now, light was simple, oscillating charges, slow motions only, small accelerations. But now, everything changes. Feynman says, we must remove limits, no slow assumptions, no fixed source, no gentle motion. Instead, imagine a charge moving, at any speed, even near light. What matters then? It is acceleration. Radiation depends on changing direction, not steady motion, not constant velocity. A charge drifting produces no radiation, but a charge turning, that radiates energy. And here comes the crucial idea. We never observe the present position. We observe delay. Information travels finite at speed c, so we see the retarded position, the earlier position, the apparent direction. That direction keeps changing as charge moves. And Feynman explains electric field, at large distance, depends on curvature of apparent motion, not the real curve, the apparent curve. So what do? He gives geometry, very clever geometry. He says, imagine, take real motion, now shift backward, at speed c, just shift it. Mathematically shift it, no relativity contraction, just translation backward. What happens then? The new curve represents apparent motion as function of time, and the radiation is proportional to the second derivative of that curve, meaning what exactly? Sharp bends matter, smooth curves weak, sharp curvature strong. Now think carefully. If motion is slow, like simple oscillator, up and down, we get sine waves, smooth radiation. But imagine instead, electron and circle, moving extremely fast, almost speed of light. Now something dramatic, something surprising. When we shift backward, at speed c, the circle changes shape, it stretches strangely. The curve develops, very sharp cusps, almost spikes, infinitely sharp limit, and near those cusps, acceleration enormous, second derivative huge. What does that mean? Radiation not smooth, radiation becomes pulses. Instead of steady waves, we get sharp flashes, one per revolution. And those flashes are narrowly directed, forward direction mainly. When electron approaches, radiation intense, when receding, radiation weak. So relativistic motion changes everything, same circular orbit, but radiation compressed, in time scale. That compression produces high frequencies, much higher expected. This effect is called synchrotron radiation. And Feynman explains why electrons circle. Magnetic force acts, force equals q times velocity cross b, always perpendicular to velocity vector, so speed constant. Direction changes only. Resulting motion, perfect circle path, momentum equals charge times field times radius. Very important relation used in accelerators. Measure curvature, find momentum. And if speeds are relativistic high, energy approximately equals momentum times c for billion electron volts. Speed differs from c by tiny fraction, almost light itself. Now comes astonishing point. If orbit circumference, classically wavelength, should be 20 meters, radio waves region. But no, because of compression, near the cusps, time scale shrinks millions of times. Second derivative shrinks, twice that factor. So wavelength collapses into optical range, even into X-rays. That is why synchrotrons shine visibly, even though orbit large. Pure relativistic effect, and radiation polarized, electric field orientation, perpendicular to magnetic field. So in summary, Part 1 conclusion. Radiation depends on acceleration only. Retarded position matters. Apparent curve matters. Relativistic speeds compress. Energy becomes pulses. Synchrotron radiation emerges. And classical theory reaches powerful predictions. We are not finished. Next we go deeper into cosmic examples, Bremsstrahlung effects, and Doppler shifts, cosmic light, and motion. In the previous part, we saw fast electrons moving in circles, producing sharp pulses. Now Feynman moves from laboratory machines to the universe itself. He says something striking. This radiation exists, not only on Earth, but in deep space. He gives example a historical explosion, recorded in 1054, a star suddenly bright, then slowly fading. Today we observe its remaining cloud, known as the Crab Nebula. At first glance, it looks ordinary, gas filaments glowing, red spectral lines, atoms ringing naturally. But in the center, something mysterious appears, a diffuse glow, continuous spectrum, no sharp atomic lines. That is unusual, because continuous light usually means hot matter or reflected starlight. But here, the cloud is transparent, stars visible through it, yet it emits light. And even more strange, the light is polarized. Polarization tells us there is order, there is direction, there is magnetic structure. So what explains it? Feynman connects ideas. High-energy electrons spiraling in magnetic fields, exactly like synchrotron. The nebula becomes a natural accelerator. Electrons move helically around magnetic lines, radiating forward beams, producing polarized light. Different regions bright. Depending on orientation, magnetic fields woven through the cloud. So classical electrodynamics explains cosmic glow. But mystery remains. 900 years past. Why electrons still energetic? Where energy sustained? Feynman admits honestly, not fully understood. Physics sometimes clear, astrophysics sometimes not. Now he shifts topic. Another radiation process, different geometry, different mechanism. Imagine fast electron, passing near nucleus. Not orbiting steadily, just flying past. Electric attraction bends path, trajectory slightly kinked. Acceleration again appears, and acceleration radiates. If electron slow, radiation modest. But if relativistic, speed nearly c, then remember geometry, translate backward at c, the bend compresses into very sharp feature. Radiation becomes forward beam, intense and directional. This process called Bremsstrahlung radiation, which means breaking radiation. Because electron slows slightly, loses energy suddenly, emits energetic photons. Accelerators exploit this, fire electrons into metal, tungsten targets common, gamma rays produced. So two mechanisms now, circular acceleration, linear deflection. Both depend on rapid directional change. Now Feynman transitions to something familiar, yet deeper than expected, the Doppler effect. We know intuitively, approaching source bluer, receding source redder. But classical formula is incomplete when speed's relativistic. Let us imagine an atom oscillating at natural frequency, standing still first. We observe frequency equal to natural value. Now suppose instead the atom moves toward us with velocity v, two effects combine. First effect simple, successive wave crests, emitted closer together. Because source advances, this increases frequency. But second effect subtle, moving clocks run slow. Time dilation appears. The oscillator itself ticks more slowly in our frame. So emitted frequency, reduced by dilation. Combine both factors, compression and dilation, we get full formula. Observed frequency equals rest frequency multiplied by square root factor, divided by 1 minus v over c, exact expression symmetric. Feynman shows something elegant. You can derive it 3 different ways. First, geometric approach, using retarded time. Second method, moving observer argument. Third and deepest, using Lorentz transformation, all give same answer. And this equality is not coincidence, it proves consistency of special relativity, because whether source moves or observer moves, physics must agree. If formulas differed, relativity would fail. So Doppler shift becomes relativistic phenomenon. Frequency not absolute, depends on frame, and something profound emerges. Frequency and wave number mix together under transformations. Time and space also mix together. This similarity suggests a deeper structure, which leads us into 4 vectors. But that belongs to next part. So part 2 summary. Synchrotron radiation explains nebular glow, Bremsstrahlung forward beams, relativistic Doppler shift, time dilation essential, all consistent with relativity. Next we explore wave vectors, aberration of light, and momentum carried, waves, momentum and light. In the previous part, we reached Doppler shift, frequency depends on motion, time dilation included. Now Feynman goes deeper. He says something subtle, frequency and wave number transform together, like space and time. That is powerful idea. Consider simple wave, cosine of phase, omega t minus kx. If observer moves, time mixes with space, under Lorentz transformation. So frequency changes, wave number changes, but phase remains invariant. Phase cannot depend on coordinate choice. That invariance means omega and k form a 4 vector, exactly like position, time component omega, spatial components kx cos. This is beautiful symmetry. Relativity not separate from wave physics, they merge naturally. Now extend picture. In 3 dimensions, wave travels obliquely, not along axis. Then wave written, omega t minus vector k dot r, where k vector points along propagation, magnitude 2 pi, over wavelength lambda. Each component represents phase change per meter direction. So full 4 vector is omega kx kz. And Lorentz rules transform them consistently, meaning all observers agree on physics even if disagree on frequency value. Now Feynman shifts again. He discusses aberration. Suppose star shines, light coming downward, but Earth moving sideways. To catch light, we must tilt telescope. Why? Because while light descends, we move laterally, so tube must lean forward. Angle satisfies. Sine theta equals V over C. This effect observed as Earth orbits Sun. 6 months later, tilt reverses direction. That confirms motion. Aberration shows clearly direction of light depends on frame. Now comes another idea, often overlooked. Until now, we focused electric field, almost ignored magnetic field. But magnetic field matters. Imagine light beam, electric field horizontal, charge oscillates horizontally. While oscillating, it has velocity, magnetic field present. Magnetic force equals QV cross B. Direction of this force? Along beam direction, so light pushes matter. That is radiation pressure. Let us compute roughly. Average force equals Q average VE divided by C. But QE is force. Force times velocity is power absorbed. Therefore average force equals absorbed power divided by C. Very general result. Momentum delivered per second equals energy absorbed divided by C, so light carries momentum. If mirror reflects, momentum change doubles, force doubles also. If atom emits light, it recoils backward. Energy W emitted, momentum W over C, carried forward. Now classical picture meets quantum theory says, light energy equals h times frequency, or h bar omega. If momentum equals energy over C, then momentum equals h bar k, so photon relations appear. Energy equals h bar omega, momentum equals h bar k, and notice something elegant. Omega k form 4 vector, energy momentum also. Both multiplied by same constant h bar, so relativity consistent with quantum mechanics. Wave picture predicts 4 vector behavior. Particle picture matches. Deep unity revealed. And one more idea. Circular polarization carries angular momentum. In quantum language, each photon carries plus or minus h bar of spin angular momentum. So polarization becomes intrinsic photon property, not just wave feature. At this point, classical theory complete. We explained radiation, from accelerating charges, relativistic compression, synchrotron emission, cosmic nebula glow, Bremsstrahlung beams, Doppler frequency shift, wave 4 vectors, aberration of direction, radiation pressure, photon momentum relation. Everything fits together. Acceleration creates radiation. Relativity reshapes it. Quantum theory interprets it. Feynman closes chapter by saying classical story ends here. But not final truth. Because light behaves, sometimes like wave, sometimes like particle, both incomplete alone, both necessary together, and deeper explanation requires quantum behavior. That will come later. For now we conclude. Light carries energy, light carries momentum, light respects relativity, light reveals unity. Classical electrodynamics reaches its summit, and from here, quantum physics begins. Beyond the classical picture, up to now, everything looked complete, elegant and unified. Fields explain radiation, relativity reshapes motion, momentum carried by light. But something remains unresolved. Classical theory predicts continuous energy emission, any value allowed. Reality disagrees. Experiments show discreteness. Energy exchanged in packets. This is where quantum theory enters. Long before this chapter, Max Planck proposed something radical. Energy not continuous. Energy comes in quanta. Energy equals h nu. Later, Albert Einstein extended idea. Light itself quantized, not just oscillators. Photoelectric effect proved it. Light hits metal, electrons ejected instantly. No delay observed. Intensity controls number, frequency controls energy. Classical wave theory fails. Wave predicts gradual buildup, energy accumulating slowly. But experiment says no. Energy transferred immediately. So we accept. Light behaves like particles. We call them photons. Each photon carries energy h nu, momentum over lambda. Earlier we derived momentum equals energy over c. Now quantum confirms. Two pictures converge. But deeper tension appears. If light particle, why interference patterns? In double-slit experiment, single photons sent, one at a time. Yet pattern forms, bright and dark fringes. Exactly wave behavior. How can particle interfere with itself? This is quantum mystery. Richard Feynman once said, this experiment contains the only mystery. Let us think carefully. Classical world intuitive. Object follows trajectory, has definite position. Quantum world different. Photon described by probability amplitude, not precise path. Amplitude spreads out through both slits. Interference occurs between possibilities when measured at single point. But distribution follows wave equation, so reality probabilistic. Now extend idea, not only light, matter also wave, electrons produce Interference patterns 2. Predicted by Louis de Broglie. Matter wavelength equals h/p. Momentum determines wavelength. Strange symmetry emerges. Light behaves like particle. Matter behaves like wave. Wave and particle, not opposites anymore. They are dual aspects. Quantum field theory later unifies description further. Fields become fundamental. Particles become excitations. Photon is excitation of electromagnetic field. Electron excitation of electron field. Vacuum not empty, full of fluctuations. Particles created, particles annihilated. Energy and momentum conserved, 4 vectors still valid. Relativity never broken. Quantum rules replace classical certainty. Now reconsider radiation. Classical view says accelerating charge radiates continuously. Quantum view says emission occurs discretely. Atom jumps levels, photon emitted. Energy difference fixed. Spectral lines sharp, not continuous smear. So classical electrodynamics, accurate at large scales. Approximation at small scales. When many photons, wave picture emerges. When single quanta, particle picture dominates. Both descriptions useful, depending on regime. This is correspondence principle. Large quantum numbers recover classical behavior. Small scales reveal quantum discreteness. So part 4 concludes. We moved beyond smooth continuous waves into granular reality. Light carries energy. Light carries momentum, but also uncertainty. Nature not deterministic clockwork, but probabilistic structure. Relativity gives framework. Quantum mechanics gives rules. Together they build modern physics foundation. From accelerating charges to synchrotron radiation, from Doppler shift to photon spin, journey leads here, where certainty dissolves and probability reigns. Yet mathematics consistent, predictions astonishingly precise, and deeper unity hinted. Wave and particle, energy and momentum, space and time, all intertwined.